Today we're going to be talking about doing Ethereum development with ethers.js. So I'm going to go ahead and just pass it on to Noah so he can get started.
Hey, thank you. And so let's see. This was working earlier. I hope this is working now. Everyone can see this, I hope. Awesome. And so today we're going to be talking about Ethereum and developing on Ethereum. There's a couple different packages that you can use to do this. I'm going to be just kind of walking y'all through the ethers.js library. And this one isn't going to be like a super in-depth tutorial because I imagine a lot of you, it looks like about half or so, are completely new to this. And I want to leave plenty of time for questions and make sure that I'm explaining everything properly here. That being said, I don't have the chat open, but Christina, if you see any questions, please feel free to interrupt me. This is an interactive. It's the best part about coming to meetups and not going to huge conferences is that you can ask questions if you have any. I'm more than happy to answer them. That being said, I will actually just hop into it right now. And you can see this is a TypeScript. I don't know if y'all are particularly care about JS versus TS. I'm not going to do any super big like typing. It's just more for the linter than anything else. And first things first, you want to actually make sure that you have it installed, which is just npm install ethers. You'll see most JavaScript or most Web3 packages have pretty nice names because there aren't too many of them. And you'll also be happy to know that if you are a really big TypeScript guy, that I haven't found a Web3 repository yet that supports JavaScript that isn't fully typed. So you don't have to go running around for third-party type systems or anything like that. And so let's go ahead and import it. And so it's really important to really think about the kind of paradigm shift that you have when you're working on traditional APIs versus Web3 APIs. Due to the just general asynchronous nature of everything, it is pretty important to make sure that you are waiting for the servers to process everything before you start asking it for a bunch of information. And just for the purposes of this, to make sure we have access to that, we're just going to wrap everything in a nice big async function. So throughout this, we'll be able to use the await. And the next step is that you're going to want to connect to the blockchain. And so there's a couple different ways that you can do that. But for ethers, we're just going to instantiate a new ethers provider. We're going to do, you can see all of these different providers that you have. I'm going to be using QuickNode for this tutorial. I work for QuickNode, so it's pretty easy for me to get access to this. If you go into their documentation, Ethers has pretty good documentation. There are not any like tutorial workflows like I'm doing right now, but it is a really good reference. But so we're just going to pop in a JSON RPC provider, and you can just look up like public Ethereum endpoints, and you can usually find a couple if you don't want to go through the hassle of all of this. For QuickNode here, what we want to do, let me make sure I'm capturing this entire string here, is this will just be essentially our API key. We can just drop this in here, one nice big long API key. And the next thing that we'll want to do, just as a kind of precursor, I'll stop there now that we've connected to tell you what we're actually going to be doing. Since there's a lot of different components to this, we're going to create our own wallet. And from that wallet, we are going to get a bit of ether in that wallet, and then we are going to send that ether to somebody else. And so that involves a couple different moving parts due to gas fees mainly is something that we'll be dealing with. Ethereum, since it is a peer-to-peer network, no one is directly profiting off of this. It's not like an AWS server where it's like clearly I'm going to spin up a product, I'm going to make money from that product and eat the network costs. Since there's no main actor that's centralized, we have this gas that is going to compensate all of the other people that are actually running these nodes on their computers. So whenever you send a transaction, you're going to essentially, that's going to go up to a node, and the person that is running that node is going to get a fee for that. And so you can either send it lower or higher your gas fees to kind of prioritize that, because miners will naturally select the higher gas fees and only go to the lower gas fee transactions if they are kind of running low on transactions that they need, which currently is not really a problem. You'll see on Ethereum, gas fees can get pretty pricey. But we need to kind of ask what the price is before we can put it in our transaction. So we're going to go ahead and call this gas price. And we're just going to ask the server, hey, connection, I don't want to get the balance. I want to get gas, not storage, get gas price. Excellent. And with that, we can, it would help if I spelled const, right? And now that we have that, we've got the gas price. Let's go ahead and get ourselves a wallet. If you're familiar with, there are a couple of mobile or web wallets that you have. The wallets are like an entire sphere, but you can just really think of it for the purposes of this as the place that your Ether holds. And you can go from as simple as like a browser extension to actual hardware wallets that you have to plug into your computer and make sure that it's essentially like cold storage. No one can access it otherwise. I'm not going to go down that rabbit hole. For this, we're just going to be generating an entirely new wallet. And so to do that, we are just going to do Ethers wallet, and we're going to create random. And this will just create us a random wallet. And then I want to go ahead and log the mnemonic phrase. And so the mnemonic phrase is going to be 12 words. This is your seed phrase, and that is what will generate both your private and public keys. So if someone has your seed phrase, they've got everything. And they're going to be able to siphon all the funds out of your account. So I'm just going to have this visible to y'all, but please make sure on Ethereum, if you're developing and other people are going to be able to see your repo, security is super, super important. Never share this with anybody. It's a big no-no. But that being said, we are just going to log this out. Okay, cool. So you can see our phrase, dentist live link stand, special illness luggage, usual tag day grass rent. Awesome. And from here, since I don't want to create a new wallet over and over and over again, what we are going to do is, instead of creating a random wallet, we're going to do wallet from mnemonic. And then we can just paste that into there. Awesome. And so now if we were to the wallet address, actually, we'll just confirm that this is wallet mnemonic. And we can now confirm that this is in fact the same wallet that we had from last time. And with that, we are off to the races. So the next thing that we're going to need to do to get a transaction going is we're going to be able to, like the wallet module is just a bunch of algorithms. So we actually need to connect to the network with this wallet. And so we're going to call that a signer, because we need to sign the transaction with our wallet. And to do that, we are just going to do wallet connect, and we're going to connect to the connection. Isn't that fun? And what this is going to do is now we can use this signer to sign any transactions that we have, because this will be able to interface with the blockchain in a way that they can verify, hey, this is Noah's wallet. Noah owns this, without having all of my information available. So obviously I don't want to just use this wallet and then someone at oopsie, I did wallet mnemonic instead, and now that's live on the internet. We don't want that. So we have this sign variable. The next thing that I want for this transaction is someone that we're going to send it to. And so y'all are going to get a look at an Ethereum address. So far we have only seen the phrase, but there are actually both a private key and a public key for a wallet. And with our mnemonic phrase, we can actually generate multiple of these. I'm just going to call it recipient. And you can see this right here, this 0x thing on a string is an example of a public key on the Ethereum network. And so this is, I might have had this at some point. I no longer have the private key. This is just represents somebody else that I'm sending this to. This could even be, for example, a smart contract. Pretty much anything that lives on Ethereum has an address that looks like this that you can send money to. But for the purposes of this, we'll just call this Jim or whatever. I think we have it as recipient right now. And so at this point, we are ready to shape up the actual transaction. Okay, cool. And so for a transaction, this is just going to be an object. And if you look up Ethereum transaction on the actual Ethereum docs, I think there are something like 18 to 20 different fields that you can send. Most of them are not needed for this. We're just going to need a couple. So if we're thinking, okay, I want to send a transaction from me to someone else, well, that sounds like we need my address, the person that's sending it. I need the person's address that we just listed, the recipient. I'm also going to want to send like how much it is. So we'll need a value. And then we're also going to want the gas price. Those are the four that just come off the top of my head, but we'll probably need a couple more here.
Hey, Noah, sorry to interrupt you. Is there any way for others to get the link pool API key and stuff, or not really?
For the, did you say the mempool API?
I think link pool was it?
Pool. Is it something that I'm showing right here? Is there? I don't know. Let me.
I'm not sure. Damien's asking about link pool IO.
From link pool. Oh, no. So I'm using QuickNode. QuickNode.
Okay. I was like, all right. No. Is there any way for people to get a QuickNode API key? Yeah.
So if you go to quicknode.com, you can register for a launch plan, and that's going to give you a free trial, and they will give you an HTTP and a WebSocket link, just like this one. And so I'm using this for consistency's sake to make sure that I can show y'all this tutorial. If you were to do this on your own and you don't have a QuickNode URL, what you can do is there are several public facing endpoints that you can use. You just type into Google, you say public Ethereum endpoint. You can drop that in. It's going to be a URL. It's not going to look exactly like this, but you could do the exact same thing, JSON RPC provider, and then just a string. It would be an HTTP link similar to this. Obviously, it's not going to be this exact one or have a key that looks like this. I will kind of throw in the caveat that people use QuickNode because it's more reliable, and I want to make sure that y'all are getting an experience that works. If you're using a public endpoint, those are often rate limited because everyone else is also using them. And if everyone else was using it, we would essentially just DDoS that particular node and it would go down. So they rate limit you with a vengeance. So that's why I'm using this. If you were just getting started, I would probably use one of those public endpoints. Does that answer? So you feel good about that?
Yeah, I think that's good. Thank you.
Yeah. Okay. And so if we're doing the from, this is going to be the wallet's address, and wallet address is going to look very similar to this, just with a couple differences. And we're going to send it to the recipient, and we're going to do value. So there's a thing on Ethereum as far as the value places. If you're thinking, oh, cool, ETH, people have like 1 ETH. I think ETH right now is like $3,500. So if we were just doing whole numbers, things get expensive really, really quickly. And so there is a measurement system on Ethereum. It goes from ETH to WEI at the very end of the spectrum, WEI, and that is 10 to the 18th power. So we got 17 zeros and then a 1 decimal place. So you get pretty granular on Ethereum. And that is what pretty much every single library is expecting your units to be in. And so there are a lot of utility functions that are centered around, okay, if we want to send this versus that, because obviously just typing 17 to 18 zeros, depending on the value that you want to send, is not the most reliable way to get things done. And so I'm going to be sending 0.1 ETH to this recipient. And so to do that, we're going to use ethers.utils. And this is an entire utility function within the ethers package. And we are just going to do parse ether. Actually, I don't want to do parse ether. That's a bit of an abstraction. We're going to parse the units. Excellent. And so the units that I want to have is going to be a string, not the number. That's important. And I'm going to send 0.1 ETH. And so this parse units takes multiple variables. And the second one is going to be the actual measurement that you want. And so since I want to be sending that, I think it is ether, the measurement. We'll see whenever I run it if that works. But I want to see 0.1 and ether. And then we want to have the gas price, which we got earlier. So the gas price can be gas price. And so we would think, okay, cool. That looks like everything that we would need. But if you were to use the send transaction function on this, it would fail. And that's for a couple of reasons. Like I told you before, there's a bit of variability on the blockchain. Things don't happen instantly. And you need to kind of have this wiggle room for not only the gas price, but what other transactions could look like. And so to kind of account for that variability, every single transaction, not every single transaction, every address has a nonce value. And this nonce value is simply the number of transactions that this particular wallet has sent. And so since this is a brand new one, its nonce is going to be 0. But for example, the hashing algorithm, we can't have things that are the same. So if, for example, my transaction failed and then I send it again, we don't want to have that exact same hash generated. So we have that nonce value that keeps things secure, that my hash is always going to be changing. Even if I send a failed transaction, that will still increment. And so to get the nonce, we're going to ask the blockchain for it. So we're back to our connection. And so we're going to connection get transaction count. That seems easy enough. And we want to get the transaction count of my wallet. We don't want to just pass in the wallet. We want to be the wallet's address. And so you could do this for anything that's on the blockchain, anybody's endpoint. If I want to go look, say Bill Gates has a wallet and I want to see how many transactions has Bill Gates sent. Or I could set up a program that every single time he sends something, I could just have a listener on this. It's like, okay, anytime his wallet does something, his nonce is going to increment. I want to take a look at that. And so this is completely public on the blockchain. And we want to be taking, this takes a second argument block tag. This isn't necessary, but I want to make sure that we're always looking at the latest block whenever we do this. If you wanted to, for example, take a look at the nonce value for an address that had happened, or like what was Bill Gates' nonce transaction, a month ago, I could put in a different variable here that would query that specific block number. And so
I'm sorry to interrupt you again. Would you mind closing the Explorer on the right hand side there?
The Explorer, the file, like yeah.
Well, if you close that sidebar, I think you could just click on the two little page icon up there. Oh, maybe I don't know how it works.
There we go.
Oh. Cool.
My Zoom was in the way. Sorry about that. Okay, cool. And so with this nonce, the only other thing that we need to account for is the gas price. So like I mentioned before, there's kind of a pool that you have to submit your transaction to. So we're sending it to a node, but before the node confirms this transaction, says, yeah, cool, I verified this transaction, it's going up to the network. There are all of these other transactions of everyone else sending it to these nodes that are there. And this is called the mempool. The mempool is kind of just pending transactions. And so these nodes prioritize transactions that have higher gas prices on them. And so we don't want to just say, okay, the current gas price, because we got this at the beginning of the transaction and things take seconds up to minutes at times. And so if you just have the static price, it's possible that your transaction could just sit there indefinitely until you try to cancel it. And so in order to combat that, we're also going to kind of put a ceiling on this. And so we're going to do a gas limit. And this is going to be like kind of a ceiling. And so it's going to slowly rise to the ceiling if your transaction isn't getting picked to go next. And so in order to do that, we are going to do ethers. And again, the utility library coming in very handy for us. The gas limit is expecting a number, but it's expecting a number in a hexadecimal format. So we are going to hexlify a number. And in this case, this is expecting a number in way. And so I'm going to say 100,000 way. So let's see, 1, 2, 3. That looks, there we go. Whatever, if I'm off, it doesn't particularly matter. Cool. And so with our gas limit all set up, this is a fair transaction, I think. It has everything that I think we should need. And so the next thing that we need to do is go to transaction. And this transaction, like we said before, we're going to use the signer. But we want to go ahead and await signer, and we're going to send transaction. And what transaction do we want to send? We want to send TX. I think that should be good. And then after that confirms, we want to just log out our transaction. That sounds fair to me. And so you'll see here, oh, cool. I think we've got everything, but we're going to see an error here, I believe. Awesome. So we got an error. And what is it telling us? Our error is insufficient funds for intrinsic transaction cost. And so it's telling us that we're broke. We got no money at all. And so we're trying to say, hey, I can pay this much in gas, and send it to this other guy and saying, no, man, you're broke. You got no money in your wallet. And so to fix that, what we are going to do, I believe I need to stop sharing for a moment to share my other screen here, is we're going to go to a faucet. And this is a good time to kind of pause for a moment and talk about different Ethereum networks. So right now I'm on a development or a test network called Ropsten, because obviously if you're just testing things like I'm testing with y'all right now, showing you how a transaction costs, I don't want to spend my actual Ethereum, because you would get no educational content, and development would be absurdly expensive. So we have these kind of mock networks that we have here, Ropsten being one of them. There are several, but you can go to a Ropsten faucet to get just fake Ethereum. And so what we can do is our testnet account address, which would just be the wallet.address. Let me actually grab that really quick off screen. Let's see, wallet. So the address for our wallet here is, oops, I tried to send another transaction. Sorry about that. And so what I did is I just did a console log of wallet.address, and that got me this. Cool. We're going to send some test ether. And so this is what you would do. This would send you some amount of ether. It's possible, again, like I mentioned before, public endpoints get rate limited. These faucets also get rate limited quite heavily, because you can see this only has 28,000 here. A lot of people are trying to get Ropsten Ethereum. There are probably some private faucets, just like there are nodes that aren't open to the public for everyone. So I actually have another wallet that is funded, because these can at times be finicky. And I think this one in particular, yeah, it drops 0.3 ether every 10 seconds. And I don't want to wait through that. So we will try one time. Let me make sure that I am sharing on the right screen here. Okay. This looks good to y'all. You can see this address here in the terminal. I'm going to say yes. Let me check these messages here. Okay, cool. And so with some of that, we can go ahead and check to see if we actually got this, so we can get the balance of our wallet here. And so naturally, anything that has to do with on-chain data, we're going to be using our connection here. So let's go ahead and I want to say this will be connection get balance of wallet.address. So we're just going to see, as promised in the, I believe, the meetup intro, how to get somebody else's balance. So hopefully enough time has passed here. And oops, we want to go ahead and await this. Okay, cool. And so this we can see is essentially not zero. This is probably 0.3, or maybe it's up to 0.6 now. I'm not entirely sure how that faucet works exactly. But if this were zero, this hexadecimal would be 0x00. And I can take a moment here to kind of talk about this, because, you know, this is a little bit weird, right? Like I'm just asking it, hey, how much money or how much ether does this guy have? And I'm getting this weird is big number and this hexadecimal value. Since weight is such a large format for these numbers, sitting at 18 places, that's not a safe number for native JavaScript to be computing. That's a little bit too large. So there is a big number.js library that pretty much all of the Ethereum libraries use underneath the hood to do all of these computations and calculations of these super large numbers. And so to get, you know, before this, we had to hexlify this gas limit. And this is returning this hex value. I don't know what this exactly is. There's another utility that would do that. But for the purposes of this, it's just not zero, which is the important thing. So my guess now would be if I took this transaction, let's go ahead. And run this again, I would hope that this works. Awesome. And so you can see this is the object of a transaction. You can see type and chain ID. So the chain ID is where we get these different Ethereum networks from. Is they're all clones of Ethereum. They just have different chain IDs. So the Ethereum mainnet has a chain ID of 1. Ropsten is 3. And this is arbitrary, whatever people put down here. You know, Ropsten is always going to be 3, but if you wanted to create a new Ethereum fork, you could pick your own chain ID, be, you know, whatever number you want here. And you can see we had a nonce of 0. I'm sure if I did this again, I would expect this to increment. And you can see the important thing is here, this is a transaction hash. And so this is essentially proof that is going to live forever on the blockchain that I sent 0.1 ether to this recipient. And so my expectation here, and you can see even that it is from me. And one last thing I'll go over before I actually show y'all this hash on the scanner here is this confirmations variable. So as time goes on, since this is the newest block on the blockchain, everything always gets incremented to the very end. It's considered a confirmation whenever a new block is put on the end in front of your block. So this is essentially how many blocks are in front of this transaction. As time goes up, this confirmations will go up as well. If you are on Coinbase, for example, and you try to send new funds or a different coin, it'll probably say pending because Coinbase wants to wait for 35 confirmations just to make sure 100% that there's no battle on consensus here. That for perhaps like 2 different chains, say they have different variables or different transactions, that would be a problem, right? So we want to wait for a little bit. And the consensus mechanisms, I can talk about that at the end if anyone has more questions here, is pretty advanced as far as deciding what goes through and what doesn't. I'll just say that essentially the longest blockchain always wins. But again, that can be a question for y'all at the very end. What I want to show y'all is this hash right here. And so we are going to go over, share again. Awesome. So you saw we had this faucet, we got the ETH from there, and Etherscan, ropsten.etherscan.io. Etherscan offers a variety of products, mostly scanning the network. This is just indexing everything and getting us all of the data on this. We can look up our hash here. And for example, if I were to not take this Ropsten, if I were to just do the regular Etherscan, you'd be looking at the Ethereum mainnet. But so cool, we have this transaction, and you can see we've now got 7 block confirmations. I think right now Ethereum does a new block every 7 seconds. So you can see this. So while I've been rambling here, we've got 7 blocks since we actually sent this. And you can see the gas price here, like the amount of gas that we paid, and we paid 0.1 ether, and we sent it to this guy. This guy probably has 0.3 ether at this point. You can see I've been using him while building this demo. So he's got up to 0.4 ether. He is slowly making his way up the ranks. And so I think that really closes out the demo. I'd like to open things up now for a Q&A on, if y'all have any questions, but I think that's a demo on how to create a wallet, how to send a transaction, how to get information off the Ethereum network.
All right, awesome. So I'm gonna go ahead and allow people to unmute themselves. And if you have any questions, you can either feel free to drop it in the chat if you're more comfortable with that, or go ahead and just unmute yourself and ask the question.
I just wanted to say that was awesome, Noah. Thanks for that great intro.
Oh, thank you. I'm happy to be here.
Noah, thank you very much for the presentation. Noah, can we use Ethers? Is it only for the backend, or can we use it on the front end?
Yeah, so Ethers is just a regular JavaScript library. I'm just showing it in Node, so I didn't have to go back and forth and build out a UI. And because I feel like that can make things a little bit more complicated once you start fetching data. But if you were to build a front-end application, say you could easily plug this into like a React app or something like that and build out a little UI where you are sending transactions to whoever you want just by dropping those into the relevant fields.
And does it connect with those wallets that are part of your browser, or does it
Yeah.
have that functionality? Or
yeah, sure. Actually, that is an excellent question that I can show y'all here.
I was curious along that same line, like how this kind of relates to something like MetaMask, and that if that's just kind of like a wallet that also has a Chrome extension, or how all this kind of relates to each other.
Thank you. Yeah, I got a appearance from my cat there. So yeah, that's a really good question. And if Zoom could get out of my way, that would be super.
Press the little arrow and it'll go to the bottom. That's the best we can do.
Oh,
you can drag it to the other screen if you like. The
see.
panel will actually swing to the other screen if you want.
Let's click that. Okay, there we go. Thank you. You're coming in clutch. Okay, so you can see this is a various account that I have. So in MetaMask, for all of y'all who don't know, MetaMask is definitely the most popular browser extension that people use whenever they're doing things on Ethereum. And there's no functionality that you get out of this that you can't get out of Ethers, but it is just a nice GUI for you. And if you're on a lot of different websites, there's going to be a big like connect wallet button that you are going to want to use. And MetaMask is pretty much supported on all of them. And so, for example, if we wanted to import that wallet, we could go to import account, and it's going to ask me to paste my private key string. And so what we can do is, if I do a new share, oh, I don't want to do that. I'm sure there's a better way to do this, y'all. I appreciate y'all sticking with me here.
We understand you're pasting the words there.
Yeah.
Okay.
And so what we want to do is the wallet private key. So we got this mnemonic up here, But this is not our private key. Those are different things. The private key comes from the mnemonic, not the other way around. So if someone gets your private key, they have all of the access to that particular account. So I could generate multiple accounts from one wallet. So you think of traditionally, you're like, okay, my wallet holds money and we call it a wallet. So you would think your mental model of that would be right, but it's not quite. Your wallet holds keys and the keys hold these funds. That's not also entirely right, but to get the next level lower is like a 30-minute talk of different algorithms and how the encryption actually works.
Could you say it's more like a credit card than a wallet?
Oh, I don't think that your credit card holds. I don't know if that would hold up. But
Can you say that your wallet is your wallet, and then each slot inside your wallet for a card is like an
card?
account?
Yeah. There you go. Your key can be a credit card. Your key can be a credit card. And so we want to go ahead and get our well, I assume we have some Ethereum. We're just going to wait to send this guy another 0.1 Ether. Cool. And so this would be a big oopsie if this was an account that was, mine. Oops, I just leaked my private key. Don't do that. But since this is a tutorial, what we can do is just paste this over to the MetaMask. And so cool, it wants us to import a new account. And I can just drop in my private key here. Boom. And you can see I've got 0.199 ETH because I got 0.3 and then I sent 0.1 twice. And so you can see now I've got this copy to dashboard. I don't know if y'all remember the exact address, but it was this address. It was 0787. Most people look at the first four after the 0x and the last four. You'll see even here, it's going to show, this first four and the last four. But so this is the exact same wallet. And this is why a lot of people like MetaMask and programs like it, because MetaMask doesn't actually hold any of my stuff. Like, for example, a lot of people use Coinbase. It's a centralized exchange. And people are like, oh, I have all of my Ethereum on Coinbase. Well, there's a saying that goes through the Web3 community. It's like, not your keys, not your Ether, So this is not your keys, not your funds. And so that gives you kind of an attack vector. Essentially, if you do something bad, you piss Coinbase off, Coinbase says, oh, well, you can't have your Ethereum anymore. Whereas that cannot happen if you're using it's called MetaMask, which is called a type of wallet, is a non-custodial wallet. Thank you for that question, Damien. That was an awesome question.
That was amazing. Yes. That was amazing. You just did everything. You got the balance. You got everything. I was blown away. Just typing like crazy. You're a good typer.
Oh,
so I guess it's fast.
Yeah, happy to answer any more questions. Otherwise, I will pass it off back to Christina.
So, and I think you put in the Ethers. What's the Ethers website?
The Explorer.
Oh, not the, yes, I mean, you can definitely put the Explorer, but I was talking documentation. I think I got it here. Is that the ethers.io?
That sounds right. I believe the docs is docs.ethers.
Awesome.
And there are a couple different implementations. I will also drop that. Yeah, V5. That is the exact link.
Awesome.
And Natter has a really great tutorial too that I'll drop as well.
Yes,
I've been
please.
following along with that one.
And so this really was just an introduction to Ethers, which is, like we can generate these wallets and stuff like that, but we didn't even touch these super complex things on Ethereum, which are smart contracts. Smart contracts are written in not JavaScript, they're written in Solidity. And you can think of smart contracts as just code that lives on the blockchain. You saw I mentioned that instead of that being like a recipient's address, that could be, for example, a smart contract's address. So a smart contract ends up having all of these same variables, just like a wallet does. Like it just is linked to Ethereum knows that it's an account, or not an account, but a contract instead of an account, and it has a couple different properties. But if you send money to a smart contract, that smart contract might have something programmed that is going to, for example, give you a different coin back. So if you're thinking of something that's mainstream, well, I don't want to say mainstream, but popular in the Ethereum world is Uniswap. Uniswap is just a bunch of smart contracts that live on the network that allow you to swap your Ethereum for other different kinds of tokens. Because Ethereum is not the only token on the Ethereum network. You yourself could write Solidity and generate your own token. It's pretty simple. I've written several tutorials on it. QuickNode. If y'all want, QuickNote has a bunch of guides. I think we're sitting at like almost 50 plus at this point. So if you have any specific questions, you can either reference me on Twitter. I'm pretty active, or there's probably a guide for it on QuickNote at this point.
How does like Hard Hat relate to all these tools?
Yeah, so Hard Hat is a JavaScript esque tool in the sense that, you know, everything that I just did was on Ropsten. And if I wanted to write Solidity code, I would probably run into some problems in that deploying a smart contract to the network is really expensive. And I probably don't have enough Ethereum and can't get enough Ethereum on the Ropsten network to actually deploy a contract. They can get pretty expensive to deploy. And so in that case, Hard Hat will set up not only all of the compiling, like if you actually wanted to deploy onto the Ethereum mainnet, you could use Hard Hat, but Hard Hat also is just like kind of your one-stop shop for Solidity development, in the sense that it will set up like a Ethereum fork on your local machine that no one else can interact with, and you can just give yourself infinite ether, and you can generate however many accounts you want to really test the different functionalities. And it also allows you to hold different plugins and test your network. Pretty much if you're trying to develop Solidity on a regular basis, and you're not just going to be using some like browser IDE, I'll drop the name of Remix. Remix IDE is a web browser IDE that allows you to write and compile Solidity. But any browser IDE, I'm sure many of y'all are familiar with, don't really make the cut whenever you're trying to do development from 9 to 5. And so you'd use a tool like Hard Hat to do that.
Gotcha. So it sounds like if you were working with like serverless functions and you didn't want to just deploy it every time, you want like someone to kind of run those functions locally. It's something kind of like that.
Yeah.
Cool.
Great question. Thanks, Anthony.
Hey, great talk, man. That was really good. I'm glad you recorded it because I want to watch it again.
Yeah, we'll see. We'll see how it turned out. I recorded on OBS, and I don't think it shares quite as nicely. But I also think Christina probably caught the actual Zoom recording. And
Yeah, I
so
sure did. I'll
okay, awesome.
I'll get it up on like YouTube or something, and make sure to share that along with all the resources that were shared.
Hey,
Amazing.
Luz, let's see. On the transactions, can you expand on the gas limit value? Is that a guesstimate number on how much the gas price is? No, so the get gas price function that I called in the first place is the guesstimate part. The network kind of does an average and says, okay, I think this is the gas price, but that could change, you know. If there's something really popular going on, suddenly the network is flooded with transactions. You see this a lot with NFT mania. I'm sure if you've been on Twitter, you've seen something about NFTs, even if you didn't want to. But that is an example of the network just gets absolutely flooded with transactions because somebody dropped a new NFT project and everybody wants one. And suddenly you're just like, okay, well, I just wanted to send Joe like 0.1 ETH for whatever. And suddenly my gas fee is like $100 because everybody else is also on the network at this particular time. The gas limit is the ceiling. So like you send a transaction with the original gas price that you asked the network for, and then it's going to slowly increment that up to the gas limit that you put. I hope that answered your question. So yeah, I would say not a guesstimate, just don't put gas limit more than you're willing to spend. So it will fail if it goes above that, and you could retry it at that point. But if you put a gas limit, I think the clients have a safety feature. Some of them, I think that won't let you send it over 1 Ethereum, but not all clients are so handholdy that will stop you from doing that. Because, you know, if you really want to get your transaction through, that's what Ethereum is about. Is if you want to get it through, you can. So if I'm saying I want to send you 0.1 ETH and I'm willing to spend 3 ETH to do that, some miner is definitely going to take my transaction that has 3 Ethereum on it. So like, hell yeah, I just made like $9,000 for sending this guy's transaction. Of course I want to do that. But yeah, thanks for coming. This was a lot of fun.
Yeah, man, thank you for coming. I'm really happy that you were able to make it.
That was tremendous. No, I think we're just all blown away. I'm thinking of 30,000 questions and I don't know which one to ask first. So thank you so much for this opportunity.
You can follow Noah on Twitter. Noah, do you want to give your Twitter or drop it in the chat so that people can follow you?
So I'm at InHeimDev on Twitter. I just put it in the chat. Feel free to either at me publicly on Twitter. I'd love to take, I get a lot of DMs on different questions. I know it's super awesome if you're willing to be vulnerable enough to ask the question in public, because odds are other people have that same question too. And Anthony did in fact know me before I was famous, although I'm definitely not famous at this point.
And he really likes your beard.
Oh yes, because I think last time Anthony saw me, I didn't have a beard. I just had this mustache. You'll see it if you follow me on Twitter. Is I have much longer hair and much less facial hair.
All right. So if anybody has any other questions, feel free to unmute or drop a question in the chat. Otherwise, we'll give it about a minute and then we can wrap things up and everyone can get on with their night.
Hi, everybody, and thank you, Noah. I just wanted a little bit of clarity just to confirm that the Ethers library doesn't allow you to write smart contracts, but it does allow you to interact with them. Is that correct?
That is an entirely accurate summation. So you can, smart contracts have kind of templates that you can see online. If you're thinking of like an API, like if I want to use Stripe, I use the Stripe API. If I wanted to use a smart contract, it's not called the application programming interface. It's an ABI. It's the application binary interface of a particular smart contract. And that is essentially the functionality that any particular contract has. And those are also all viewable on that Etherscan website. If you type in any contract, you can go and look through the source code for it, which is another very cool thing. And I won't go on a big long spiel there, but it's one of the reasons I am super excited to be in this space. Is everything is kind of open source by default and you can't really stop that. But that's exactly right. Ethers will allow you to interact with the ABI of any contract. That's also a great question. Thank you for asking.
Thank you.
Hey, no, great presentation. Thanks. If we wanted to know more about this, learn more about this, what are some next steps we can take?
Yeah. So I mentioned quicknode.com/guides. That's that's a plug from me. I work for Quicknode writing guides, so a lot of those are by me or have some sort of influence from me. Outside of that, Ethereum.org has a lot of independent blogs and write-ups over there that are all open source. That's a great one. I think Anthony probably dropped one of Nader Dabbitt's guides. If you're like a pretty experienced like full stack developer that's looking to go to the Ethereum space, that's also a really good one to check out. But yeah, those are specific resources. I would say if you're like someone that already knows a bit of programming and is looking to jump into the space, it's pretty learn as you go. I know a lot of programming is like that at this point, but the mental model is not so different than you think it is. On the front end, you're still fetching data and putting it on a web page and interacting with things that are typically black boxes for you as a front end developer. The real difference is for the backend developers, where they're used to working with like databases and APIs. They're now writing smart contracts instead, and that's a bit of a different beast. But that's the main thing that I would look at, is using those packages like ethers.js and web3.js on the front end or back end. If you're running like a node service, those are definitely fine to use on the server side. But if you're more interested in like the guts and the internals of Ethereum development, you definitely want to, I'm not gonna say you want to, you have to learn Solidity. That comes with another layer of knowing about gas optimizations and security, because these smart contracts hold at this point multiple billions of dollars. of revenue. So making sure that you can put code out there that anybody can look at and then trust that they can put their money into it without some hacker coming along and taking everything. You see in the news pretty frequently, some network gets hacked because they had some bad smart contract code. So you have to be really, really knowledgeable about the internals of how the Solidity compiler works, because not only can you create code that's insecure, that puts people's funds at risk, you can also create code that is unnecessarily expensive. So whenever I submit a transaction to a smart contract, part of the gas fees are higher for that than like a traditional transaction, because it has to do more computing. So the people that are running the nodes obviously get paid a little bit more for that, because it was a bigger lift to actually get that code to run. And so you also have to be really conscious, because every single line that you're adding is at times just additional cost to your users.
That is one of like the really interesting things about developing on the blockchain, or in Ethereum in particular, that, you know, a lot of us are used to like hearing like, don't worry about like micro optimizations and so on and so forth. And in this case, like all the code that you write is like really consequential, security wise, because you could, you know, write some code that ends up losing people millions of dollars, and also it could end up costing you a ton of money if you write like very unperformant code. So it's interesting. Yeah, so yeah, I see that Anthony just dropped that. So in the first few hours, 3.6 million ETH was stolen. And 3.6 million ETH is a whole lot of USD. I can't do that kind of math in my head, but
Yeah, 3.6 million.
what is that, like 9 million
time
or something? Like 9 billion or something? I don't know.
Let's just say that the 3.6 million that Anthony now has is the reason why he's calling us from Mars.
Yeah. So yeah, it's like I was telling on the Solana network, there was a bug recently, I think like yesterday or before yesterday, and it caused some issues. You know, nobody lost millions of dollars, but I was telling the developer who was fixing the bug, because he felt like really bad. I was like, man, like I think you guys are like so brave, because you're like you're like writing this code that like is not just, it's not just like, you know, some web app. It's like there's people's money at stake. So it's it's kind of like a heavy burden, honestly.
And I'm sure people that work in kind of like open source as well as closed source at their full-time job will kind of attest that there's kind of a difference in code quality. You know, in open source, people like, you have to submit this pull request. A lot of people are going to review it. They're going to be really nitpicky about your code because everyone sees it. And maybe at closed source, occasionally you do some hacky thing just to get the job done. But that just doesn't really happen at all in this space, because unless you're writing just some internal API for some library or whatever, if you're actually putting something out on the network, everyone's going to see that. So every single thing that you write has to really be top-notch stuff. And you see a lot of really talented developers are moving to the space, I think, in part because of that.
Yeah,
Yeah,
plus,
it's really
not losing millions of dollars is a great incentive to write excellent code.
Yes, nothing like it. Nothing like it.